For companies making components, there are specific safety challenges. I like to think of it as positive trust balance. You need engineering rigor, you need validation, you need feedback, you need safety culture, and you really want to have a standards-driven approach to safety. Part of this is going to be safety performance indicators. If there's a vehicle manufacturer that's buying a piece of equipment, they're going to need to know what they can expect from your component, not only in functionality, but in terms of safety, and they're going to want data for that. I expect integrators will start asking for more than conformance certificates to something like ISO 26262. They're going to want to know component safety cases. It's not going to be enough to say, well, this is a 26262 ASIL-D component. They're going to need to know what kind of situations it's designed to handle, what kind of situations it has a problem with, and what assumptions have been made about the operation of the system. For example, if you have a sensor that's great in normal hazy days, but has a problem in direct sunlight or has a problem in rain, you need to know those sorts of things, in addition to whether it's safe for its intended operational design domain. It's almost certain that as this technology matures, there are going to be lessons learned, both during development and during deployment. It'll be essential to have field feedback on quantitative metrics for performance. What's working, what's not working, what are surprises, things that you thought were going to work but don't, because either you didn't understand the technology, you didn't understand the full scope of the requirements, or the world changed out from under you and things are different than you assumed they were when you designed the system. So safety performance indicators, SPIs, will be essential to feed back not only to the component developer, but to the vehicle developer so they can understand how the performance and assumptions change over the life of the equipment as they're issuing safety updates. Another challenge is scalability past pilot vehicles. Accurate perception and prediction is still a work in progress, and getting things to work pretty well for 1 car or 10 cars or even 100 cars is at a vastly different scale than getting something to work for millions of cars, where all the rare edge cases suddenly become daily events for some vehicle in the fleet. I expect that this is going to force a transition from a brute force data collection approach. As the long tail of edge cases and odd things happens, you're going to need to take a more structured approach to talking about safety. You're going to need a safety case to not only say, well, we haven't seen a problem in so many million miles, so probably it's okay. You're probably going to also need to say, and here's why you should believe that's probably true, because we've thought through it and it makes sense that we haven't seen any problems. A key point in the safety case is going to be resolving the issue of potential multi-sensor correlated failures. If you have multiple sensors that do okay, you can say, well, I have multiple sensors that do okay, so what are the chances they all fail at once? And the issue is that there are going to be common cause failures across the sensor modes, and you have to think about those, you have to reason about them, you have to account for them in your safety case. Here's an example in which a camera didn't see this man who might or might not be about to cross in front of my car in downtown Pittsburgh. A contributing factor was there were a lot of vertical edges that caused some performance problems. But if you say, okay, the camera didn't see him, the radar will, well, the radar sees the man, but it also sees the trash can, it also sees the light pole, and it's not clear if it'll be able to distinguish them, especially since the man is still standing still right now as I approach him. So there's nothing moving. It's unclear if a radar would have seen that man or not. And same issue for the LiDAR. It might think that the man and the pole and the trash can are all part of the same object. Now, every particular system will have a different approach to this, but the point is that the limit to safety is going to be having sensor fusion algorithms that are dependably diverse so that you make sure they don't all fail in the same way on the same scene.